Do you have
Yeah, 49 to 1. Well, it's not in the middle, it's in there.
right?
But I've got a 49 to 1 on there, so it operates on 10, 15, 20.
Which one's the right one?
This one?
And 15. I get beautiful signal on 15, so it's quickly becoming my favorite. I will get rid of this.
Well, it's because of the atmosphere.
Oh, yeah.
15 and 17 are fantastic. Right?
Well, I haven't tried 17. I'll have to,
Oh,
I'll check. I'll see if it'll.
Can you see the new set of slides now?
I was running like 9 watts and I got this guy from Macedonia.
On the Zoom?
One voice. I mean, there's times during the day.
I see it.
Goodness, it's all.
Okay, we'll talk a little bit about digital integrated circuits and gates and PLDs. Let's steal it, go. Well, they're all gone. All right, so as we mentioned before, there's kind of two major families, TTL, which is transistor logic, and complementary metal oxide semiconductor or integrated circuits, except for the exotic stuff that I mentioned earlier. CMOS or complementary metal oxide has the advantage that it's a lot lower power dissipation than TCL devices. And I guess they're up to the point now where they're probably just as fast or faster. They have a higher noise immunity because they basically switch at half of the power supply voltage. Where in TTL logic, it's down. Most TTL logic runs at 5 volts, and they will switch in the like 1 to 2 volt range to change state on the output. There's also a family called BiCMOS, which is a hybrid of the TTL and CMOS. So it has a CMOS front end to get the high input impedance. It has a bipolar output section, so it has low output impedance or much more drive capability. That's the other basic difference on a CMOS device. Fan out, which is how many input devices you can connect to it, is smaller than it is on TTL. I forgot the maybe Michael, is it 10 or 16 for TTL?
I don't know.
It's at least 10.
Yeah.
I've forgotten. This is a typical circuit of what an actual TTL gate looks like, how it's constructed. And you see that the inputs are directly off of the emitters. So when the preceding stage applies a ground, the low voltage, you get current coming through the emitter. And so you get a base emitter current flowing. When the preceding stage is at a high voltage, it shuts this transistor off. At least one of the gates. If you look at the CMOS one, okay, it's a very different structure. Of course, it's made out of field effect transistors as opposed to bipolar. And it's more of a voltage controlled device as opposed to a current flow on the input. So what's an advantage of CMOS over TTL?
Low power consumption.
Dissipation.
You gonna go for delta?
lower power section.
Why do CMOS digital integrated circuits have high immunity to noise on the input signal or power supply?
Something about the switching. Yeah, you said it was 1/2.
It's approximately.
Yeah. I remember you saying.
Which of the following is an advantage of a bi-CMOS logic?
Best of both worlds.
Usually when you combine stuff, it's not as good as either one. High input, low output. Okay. You may have tri-state logic, and it doesn't matter the family, whether it's CMOS or TTL. The difference is the gates are designed so that you can put the output into a high impedance state. So instead of the output being a logic 0 or a logic 1, which is usually a low voltage or a high voltage for positive logic, it basically makes the output an open circuit or high impedance. So when you connect a bunch of tri-state devices, the outputs together, and they're all in the high impedance state, okay, and that's how we make a bus. They don't have any effect on the bus or the connection between them until you enable one of the devices to output a 1 or a 0, and it will control the state of that common bus.
So you can take it completely out of the circuit.
Essentially. Now, that doesn't happen with the inputs, because the inputs can still be on that same bus, not necessarily the same device, but other inputs. They'll see the state of their device. And you would normally want it to either somebody be in control, so it's always in a 0 or 1 state. This is, I had trouble finding a schematic for a tri-state NAND gate. And it came out, it was in black, so it didn't show up very well. And I did a little truth table on how that would operate. And in this case, you see the little circle down there on the enable, which means it's negative, it's an inverter. So whenever the enable signal is 0, means the gate's enabled, so it's going to act like a normal NAND gate. So it's going to be a 1, except when both inputs are a 1. When the enable gate is high, then the output is going to be indeterminate or high impedance. It's neither a 1 or a 0. It's not going to be there. So what is tri-state logic?
I like B.
Huh?
I like B.
Well, it sounds like it might be.
Yeah.
What ternary math is.
D's pretty good too.
Okay. So we've got different symbols for the different gates. And they're showing a selection on figure 6, E6C, where we have an AND gate, an AND gate, an OR gate, an OR gate, an inverter, and an unknown gate. Why they threw that in, I don't know.
It's a slice of pizza, but it's telling you it's lunchtime.
I bet you some manufacturer uses that for some special needs.
You know what?
I've seen the symbol like that. So in that figure, what schematic symbol is a NAND gate?
4. Which is,
No,
No, it's number 2. It's got the
Oh,
little
yeah,
dot
oh,
on it.
NAND gate, and not AND gate.
yeah, because it's not an AND gate.
Right. What symbol is a NOR gate? Not a NOR. I mean, it's not an OR.
That's. Geez.
Right. What symbol is a NOT or inverter?
It's 5.
5.
C.
Right. This is just kind of a practical one. When you design a circuit, and most of the integrated circuit packages will have multiple gates in them. Like usually 4 AND gates, NAND gates, 4 gates, whatever. Maybe 4 flip-flops. So if you don't use all of the inputs or all of the gates, you want to use pull up and pull down resistors to force those into a 1 or 0 state, whichever one makes sense, so that they don't switch from noise, which would create noise in the circuit because you're turning the output on and off because you got noise on the input of those floating signals. So you don't want any basically floating inputs. And in a lot of cases, you may want to put a pull-up resistor on the output just in case to force it to a high state. So what best describes a pull-up or pull-down resistor?
Mhm. Hmm. B.
Yep. It's usually a 10 K ohm resistor tied to your positive voltage source or to ground, which is sufficient. Comparators. That's a little bit different. It's kind of a hybrid in that it's not totally digital. It has an analog input with a digital output. So it has 2 terminals. One's a reference threshold, and the other is the input. So when the input exceeds the threshold voltage, the output of the comparator will go true. When the input becomes less than the threshold, the output goes false. 1 or 0, however the logic is efficient. Now, if you have a noisy signal and your threshold happened to be 2 volts, let's say, and I put the 2-volt signal is going to switch high, but with sending noise on it, it might get below 2 volts. So it would just toggle every time there was a little negative noise spike, toggle off and on. So to get around that, they built in what they call hysteresis, such that if I have that 2-volt threshold and I get up to the 2 volts and the output goes high, the output will not go false until I drop whatever the hysteresis voltage is below threshold. So say it was a quarter of a volt. So until the voltage dropped back to 1 3/4 volts, it wouldn't go false. So you have that hysteresis set wide enough, and in some cases you control it. So that any noise in there is going to be in the hysteresis region. If your input voltage is right at getting close to the threshold. And this is kind of what one looks like, where we have a threshold or V reference. And then your input voltage, and you see it in the little animation going high and low. I thought that was cute.
So. Is this the same type of thing that they would do when you have the problem where you have like contact bounces on switches, and you push a switch and it bounces a couple of times before it settles out and turns the circuit on and off and on and off when it in those bounces?
Yeah, but normally, what they do for switch bounce is just put a delay in,
Okay,
with kind of like a one shot, and it triggers it, and it will not look at the output for some period of time. So
Okay.
the switch bounce, if you do it right, it's bouncing in that
Right.
period. And that's why you do switches. You normally want to open it, because when you open it, it doesn't bounce.
Okay,
When you close it is when it bounces.
right.
So depending on what you're doing in the circuit, you may want to have it where it's normally closed and you open it for your signal, like on a limit switch on machinery, relays and milling machines stuff. You normally set those up so they're all chained together, conducting current. And when one of them opens, okay, that generates a signal that you hit a limit switch somewhere.
Yeah, I've noticed a lot of radios have they're like an electronic switching, to turn on the radio. It's like, you can hear the circuits being activated before the power ever comes in.
Yeah. Well, especially if and most of them will have some relays though.
I guess it's because that switching action with a mechanical switch can be kind of rough.
Yeah.
To get started.
So what happens? Oh, okay. Did I go too quick? What happens when the level of comparative input signal crosses the threshold?
I had to read that a couple of times because I didn't see an answer that fit, but. Because I was there, so I went back to read it to see, okay, is it going above the threshold or is it dropping below the threshold?
Well, it's talking about
Well, it says when it crosses it, so it's obviously exceeding the threshold.
Wherever, well, it's regardless of where it's at.
Well,
If
true.
it crosses
Okay.
the threshold,
And actually,
it changes the
it's gonna
output.
cause
Right.
an output change.
it should be going the other direction. You're right.
That second.
And that's why the answer is it changes state.
Yeah.
Didn't say whether it went high or low.
That's why I had to read any questions over it.
Yes, one thing you don't hurry, read the question maybe twice. Because a lot of times, if you read it quick, you'll get the wrong idea of the question.
Is there a time limit?
No, well, there's not a reason. I mean, I'm not gonna stay there in an exam for 3 hours. Although I did once.
For one
Online.
person?
No, 2.
Yeah, okay.
One guy did his,
It's only an hour and a half.
one guy did his technician, his general, extra.
Yeah,
And
yeah.
then we had another guy. I don't know if he did it once or twice, and it was the first time through online, and it was 3 hours. What is the function of hysteresis in a comparator?
Yeah, you said it's
Called
because
unstable outputs.
because of noise.
You don't like those unstable output signals. It's like spurious emissions.
bad.
actually, and it would cause further emissions. Okay, so particularly today in modern radios like SDR radios and even some of the non-SDR, they'll make use of what we call programmable logic devices, which lump hundreds, if not thousands, of gates, digital gates, AND gates, OR gates, inverters, in a big matrix. And you can program that matrix to interconnect all those devices the way you want. So you can make just about any kind of combinational circuit within the limits of how many devices are in there. And they come in different sizes by PLDs, small ones up to very large ones. Of course, large ones cost more. And a lot of them are field programmable. So you don't have to order them from the factory already programmed. You can actually, you know, do the application software to design it. You put in your Boolean logic and it will come out with basically a map. And they have what the connections between the devices are like fuses. And you can below the fuses to disconnect and leave the ones connected that you want. At least that's the way some of them work.
How is this different from a PLA?
I don't know that it is, the name's different.
Okay,
It's a PL device. Where a PLA refers to programmable logic array,
right,
which is a programmable logic device.
okay.
It's just a different name, the same thing.
It sounded like it was the same thing.
And I think different manufacturers have some different names for them
Of course.
and their own proprietary software that you know, like Xilinx was one of them. I guess they still are. Haven't done that a long time. So you use CAD software in order to configure and program. This is a very, very simple PLD, which has some inverters. It has a multi-input AND gate, two of those, and this OR gate and whatever this output driver probably is. So there's all these little fuses allow you to connect these two inputs. And actually, I would have thought they had, oh, okay. So, yeah, you've got an inverted and a non-inverted output to it. So you can make quite a few different circuits by just the arrangement of those 8 fuses.
How do you blow the fuse? I mean, I'm looking at only, is it a connection? Is it something?
Some of the old ones actually, you blew the thing. It was a one-time program.
Right.
Now I think some of them you can actually reset. It's more like a circuit breaker. You can reset them, I think.
Is it like done like the software?
You program the software.
It's like a little program running between those circuits?
No, you,
Or a chip?
in order that there's programming inputs on the device, which allow you to select which of those basically fuses or connections that you want to make or break. However it's physically done, I can't tell
Yeah.
you. But a lot of the field programmable ones you can redo. It's kind of like an electrical, like an EEPROM, double EEPROM, electrically erasable, where you could reprogram it.
It has the hard circuitry, but it allows for programming in the middle.
To change the circuit.
Right.
Control what's connected to what.
Yeah.
So what is a programmable logic device? E sounds good. That's the right answer too. All right. Well, let's see, what are we at? Went longer than I expected.
We asked,
A lot of time in trying to question. I don't know why my computer is behaving so slow today, but I guess I gotta reboot.
You probably ought to turn off the recording if you don't want to make them so big.
Yeah, well, I got another 20 minutes to go for it to,
time's out.
no, it has to process the recordings.